Hi again, and let's solve today's LeetCode problem. What do we have today? Medium task. Medieval operations to make binary array elements equal to 1. You're given binary array nums. You can do the following operation on the array any number of times, possibly 0. Choose any 3 consecutive elements from the array and flip all of them. Flipping an element means changing its value from 0 to 1 and from 1 to 0. Return the minimum number of operations required to make all elements in nums equal to 1. If it's impossible, return 1. Well, pretty interesting task. For example, here we can only choose 3 consecutive elements. So here we can do this, then we can do this, and then this. Wow, here it's not possible. Okay, how can we determine if it is possible or not? Really interesting task. What they do here is just reverting numbers from first 0. And yeah, it works. So we're reverting here this 0, we're getting this. We're reverting this 0, we're getting this. We're reverting this 0, and now we have all the numbers reverted. So yeah, constraints. Numbers length bigger than 3 or equal and can be big. Numbers are always 0 or 1. The first thing that comes into my mind is to make a kind of pointer that would move through the array, look for zeros, and turn them into ones. For example, we have array 0, 1, 0, 1, 0, 1, 0, 1. We're turning this 0 into 1. We will get 1, 0, 1. Then we're turning this. We're getting 0, 0, 1, 1, 1, 0, 0. Then we're returning, reverting these 3 zeros. 1, 2, 3, and ones. Then we're having this 0, and we know that we cannot return it, revert it. Okay, so here is the same. We're reverting this 0, then we're reverting this 0, the 0, well, 1, 0, 0, 1, 1, 1, 1, 0, and then we know that we cannot do anything more. Can we simplify this solution somehow? we can calculate number of reversions. So we can calculate something like this. 1, 1, 2, 2, 3, 3, 4, 4. And for example, if we were taking this 0, 1, 1, 1, 0, 0, then we will have 1, 1, 1, 1, 2, 3. And the result the result number of flips should be equal to 3, I believe. Should be divided by 3. Well, is that correct? In my case, it is correct. So if I will add 0, 0, 0, then I will have 5, 6, and I will be able to pivot it, to flip it. Let's check. 1, 0, 1, then 1, 0, 0, then 1, 1, 1, then 1, 0, 1, then 1, 0, 1, and no, I cannot. Let's recheck. Yes, it's correct. It's correct. This one is not correct. Ah, no, it's correct. Yep, then this one is correct as well. Then this is correct. And this one is correct. And after that we cannot do anything. Okay, how to calculate if we cannot revert it? Three. Let's check. If the result is 1, means we should, or we can do this. 1, no, it would not be like this. It would be like this. We will increment it. 2, 1, 1, 1. No, it will be only more complex. So let's just make the simple solution. Pointer would be equal to 0. Let's name it I. While I less than, this is the final I, length is 6, I is 4th, I less or less than nums length minus 1, I less than numbers length minus 1, I less than 5. That's right. I plus plus. And here, if nums ith equals to 0, then we will revert 3 elements. Nums I would be equal to 1, nums I plus 1 would be equal to how to do it easily. 1, not 1, number, not 0, yep, or we can just use plus 2, 1, 0. Two. Let equals to I 1, 2. Const I plus 1, I plus 2, nums 1, nums, well, it doesn't simplify anything. Number. Okay, I plus plus. And then when we get to the end, if I equals to 5, then we're getting, if I equals to 5, then it will be, oh, if I equals to 4, 3, it would be less than 5. If I equals to 4, it will be less than 5. Then I equals to 5. We're quitting this loop. And we only have to check that last two numbers are equal to 1. Return this equal to 1 and is equal to 1. Okay, let's check if everything is right in my algorithm. Let's say that we have an array of 3 elements, for example 0, 1, 0, 0, then I would be equal to 0, I less than 2, I less than number's length would be 3. 3 minus 1 is 2. So we have to say that it should be less than 1. And when we have array the length of 6, 1, 2, 3, 4, 5, 6, last should be 4. 6 array should be less than, sorry, I'm puzzled. Here we have array of length 6, last index should be 4. So we have to say that I should be less than 5. Here we have array length of 3. Last index should be 0, 1, 2, 3. Last index should be 3. Sorry guys. A mistake, yes. Minus 2. I equals to 0. I less than number's length minus 2. Numbers first at the index of I. Let's name it just number. If number is equal to 0, then we will move next ones. But it's not equal to 0, and we will just increment. 3 minus 2 is 1. I not less than 1. 1 is not less than 1. This is why we're getting to this, and we're returning false. But if we have this, then I is less than 1, and we will have this. Number is 0. Numbers I first would be 1. Numbers I plus 1 second would be 1, and this one would be 1. I plus plus, and then second is 1. That's it. Okay, I think it should work. Numbers I plus 1. It should work. Don't see mistakes. Let's check. No. We have to calculate the number of operations. Operations would be equal to 0. And here we will increment number of operations, and here we will return the number of operations. In this case we will return number of operations. Let me remember my mistake. Wrong return value. In other case we will return -1. Yep. Let's submit it and check if everything is okay. Yes, everything is okay, and solution is pretty optimal as I see. But I wonder what can be other approaches. But let's start with calculating the time and space complexity. time complexity would be O of n. We just have one loop through the array, and space complexity O, big O of 1. So constant. We don't have any additional arrays, we're just mutating numbers array. Yes. Sorry guys. I don't think it's possible to simplify this solution because binary search we cannot use here. We don't have any monotonous function. But let's look at other solutions anyway. What do we have here? Just the same approach. Just exactly the same approach, actually. Yeah. Greedy. Exactly the same approach. Beats 100%. Oh my god. And what do we have? Exactly the same thing. Wow. I like this solution. This is much more I would say elegant. We're just using XOR operation for one, and yeah, it will work. Really cool, really cool. I should remember this. Just use XOR operation like really nice. I really like this approach. Includes wow, but this is one more loop through array. Bad idea. Let's sort, but it's sorted by votes. Flip next to. Is it the same? Yes, it is the same. Okay, guys, I think this is enough. Thank you very much. I think we did it today. Poop, poop.